So one of the very simple calculation we did with all the low carbon analysis is that if you just use recycled material, you actually already save at least 80% of a carbon footprint. Of course, right now it comes to what type of remanufacturing technology comes with it. But that technology is available online to everyone, every one of us. And there's some very simple technique. Go back to the way how Romans built aqueducts. They use rice husk, organic fiber to reinforce cement. Why don't we use that? Why? Why are we doing that? The Chinese built the Great Wall with rice husk, grind it down. Why not? Why can't we do that today with our cement? So, I mean, this has come up with questions. So why we wanted to address this idea of imbalance. Okay, so I think this is a huge amount of opportunity for any business people here. So I think for most of us, we call ourselves not designers or engineers. We really have to mush together and call ourselves innovators. So I think everybody's an innovator here today. So I just want to, this is the Economist cover. Will we ever invent anything useful again? This is basically the question of our generation, really. Our generation, like, we got the TV now, we got the refrigerator, we got the car. I mean, what do we do? Like, well, I have 30 years ahead of myself. What do I do? So, how about we take the stuff that's in the sewage, and then we see if we can turn that into food that we can eat it back again. Okay, that sounds kind of nasty, but I think Taiwan actually promotes itself as such a organism, actually, and they actually bought an article, actually without our permission, using part of our building actually in there, as a way of saying Taiwan is cutting carbon emission by turning trash into green gold. And that building in there and all that data is actually from my office. That's the building we built. So I quickly show you, this is a building made with no glue. Okay, we try to not use any glue, so we can recycle every single resources. All PET is PET, PC is PC, HDPE is HDPE, metal is metal. And even the metal bone of this building is made from actually scaffolding that's left over from highway constructions. So everything is literally coming from trash. So we collected 1.5 million PET bottles from Taipei citizens, and we created 2.7 million hexagon with 16-edge with a shear bolt interlocking brick without using glue. And that can resist typhoon, integrated with BIPV. You see all that black stuff is actually solar panel. And natural lighting, insulation using air rather than having all these, just using air. Air is the best insulator. Vacuum is one of the best insulator. And all that LEDs is actually being powered by the renewable solar energy. And this building is now the part of the art museum in Taipei. It's for the 2010 Flora Expo. Do you have a question? It's actually financed by a private company called Far Eastern Group. They are actually the world's biggest PET supplier, and actually a lot of Nike and Adidas, global brands actually use their material. And so, of course, their future vision is having a world all made from recycled material. Okay, so we are part of that team that innovate this building. And one of the things we do on a daily basis is we have to dialogue this technology against the best institution around the world. So we use that. Do you guys remember the aquatic stadium, Beijing Olympic? It's using that material. It's like called Teflon. It's like this really ETFE. Yeah. Okay. Sorry. This is an intermission. I want to introduce my colleague here. My colleague is also my German colleague, also working with me in Taiwan. We've been doing a lot of innovation between Germany and Taiwan. And so we are basically comparing existing sustainable systems, and we are trying to make it even more sustainable, even lighter, even less glue, even less chemical, and all using recycled material. Of course, the result is not very surprising. If if you have the dedication to get into that nitty-gritty stuff, you can prove that it actually become more sustainable at all fronts with better performance. Of course, and here's just quickly to show you an innovation like that. You can also a lot of times like, oh, do you guys make a lot of money? No, we don't. But we do make a lot of public headway in terms of media because there's a lot of things that's never been done before. We're breaking wave and making sure the safety for the visitors who visit the building. So it becomes a sensation global media-wise. Wins a lot of awards, even Wall Street Journal. We're New York City's Mayor Bloomberg's mentor fellow. And I just want to quickly show you some. Oh, I also want to show you a little vase of an alcohol that we created with Taipei City government. Taiwan has a culture of being very thrifty. I think the Asian culture has a culture of being very thrifty. So for the last 10 years, they have a whole system called Trash Do Not Touch the Floor program. Okay, so any trash, any recyclable cannot touch the floor. You have to hand carry, and you have to go to a recycle bin, and they have to collect at a certain time. Okay, I want to. Here's a little vase of alcohol, which I'm sterilizing the microphone. Okay, but you guys can smell. It actually smells kind of like grappa. But imagine where this alcohol is coming from. It's coming from Taipei's food waste. Okay, so we actually built an infrastructure in Taipei, recycling the food waste. It's actually it's quite taking the food waste. Just imagine in New York, all this restaurant. Do you know where all that old food, like leftover food, went? Just imagine all that can turn that into biofuel. It can turn that into energy that the plant actually is power itself. Because we divided the food waste into two types. One is a drier type, drier bulk. The other is a wet bulk. The wet part, we actually distill it like grappa, and like grappa, like maca, and yeast, and turn that into alcohol. From alcohol, we went to create ethanol glycol for bio-PET, bioethylene for all the plastics. So this building and this external wall of this building is also created all using bio-PET too. And so this is a project helping Taipei designer and engineer to understand what are the resources that they're missing. And this is actually a functional plant currently. It's one of a kind in the world. And this is the one that just completed this year. Actually, just last month, actually. So you can see from the ceiling all the way to the exterior curtain wall, all the way to the interior fixtures, it's all made related to this alcohol content that's derived from food waste. Another thing is my job as I'm still teaching at Cornell University. I'm specializing in structure and architecture. So what we did is we gave them 2 sheets of polypropylene, which is orange juice carton that we throw out every day. We extrude it, we turn that, and we extrude it into 2 boards. Very 2 thin, like paper-like boards, only around 200 grams per sheet. And we gave them also a 50 grams of PET yarns. We asked them to create a bridge. So basically, they only have materials that's only 500 grams or less. And we asked them to create a bridge that can support a human body, spanning across 1 meter. Sorry, 1 meter is 1 yard. Everyone in the beginning thought that's not possible, and they cannot use glue. But with a little bit of structural engineering, human ingenuity, the freshman students can make that work. Really. So I just think there is so much hope for our generation to just use as little resources as possible to create just as much interesting, creative products or buildings or potential marvels that we might actually find very interesting to have. Another thing we do is we do a high level of communication with art. I think we work with Museum of Rome, Museum of the Nazis in Rome. So we are trying to show that recycling is a new trend. So of course, for most of our artists, that might be a concept, but they don't know how to actually implement that material. So we volunteer to become part of that, to work with artists to use recycled material to become the base material for their art. This is one of the economists last year on the third industrial revolution is talking about a series of new material innovation. And this page is talking about our work using recycled plastic and rice husk. So we've been highly specialized in working with wheat husk and rice husk to try to turn that into this material called silicon dioxide, which are a natural glue, mechanical glue that allow material to come together. So you don't have to use chemical. So because trash material are naturally quite weak, that's why they're not very sexy. That's why you cannot use in the high-end products. So that's why we're trying to reverse that without using chemical. So in general, we do three things. We take the stuff you eat, which is the grain byproducts, which are the rice husk, and the drinking product, which are the packaging. Most urban cities require more and more packaging material. Just go to any of a convenience store these days or a supermarket. You will see more packaging than ever, especially plastic packaging. One of the key is these packaging are actually non-toxic, so they can actually create packaging quite efficiently. However, can we do that and recycle these materials and turn that into a higher end product so it stays in the system for much, much longer? So we thought about the idea of turning that into building products. And e-waste. E-waste is a huge problem. It has heavy metals inside, it has precious metal, rare earth. It also has plenty of precious plastic. So we're taking that material and turning that into something attractive and building material that can last for a long time. So I just want to quickly go through some of the supply chain, but maybe I just go through some of the project. You will quickly see how all this thing come together, okay? I won't go through that. So this is a project that we're turning recycled PET, we're integrating with rice husk. Series of new collaboration. We're working with a big American company using recycled material for a lot of potential products and architectures, okay, using all waste material. I want to also show you, this is during the earthquake in China, Jackie Chan Foundation's donated 27 schools in the disaster stricken area. One of the big issues is how do you create a sustainable bookshelf without using a lot of transportation? I'll just start with something small, let you guys get a feel of what type of work that we're doing. You have to create 27 schools of library. You need to be able to hold books. You have to be able to go in and assemble using kids. They can help you to assemble the shelf. So basically we designed this 4 meters by 2 meter shelf system just using 5 boxes. And within 40 minutes and just a rubber hammer, you can create a shelf system that's able to sustain weight. recycled aluminum and PC panels. And then you can create a whole pavilion next to Louis Vuitton and to look somewhat fashionable. We're working with Nike, this is already finished, to come up with one of the world leading tier 0 most expensive Nike store in Shanghai, all made from recycled material. So the ceiling is made from recycled DVD, the joints are made from recycled aluminum, the yarns in between, the green yarns are made from recycled PET. And all the skeletons printed from PLA. And the floors are just unfinished. Okay, rather than putting these marble floors, we're just having this natural finish, and the lightings are LED, so you can change the space all the time. And everything is 3D printed, computer analyzed, so you can change the space within days. You can change to a complete different, so you don't have to keep remodeling a retail commercial space. And this is in Shanghai. And of course, with all the famous athletes that we always work with. And this is another project that we did. Most of the project I'm showing is all within this summer. Okay, so we have a lot of work, so I won't go through. This is what we did. I don't know if you guys know this Nike shoes called Flyknit. It's one of the shoes that's made from only PET that's stitched together like a sock. Okay, so you can recycle the shoes like a plastic bottle. Why can't shoes design like that? So why can't a museum for the shoes, or the display for the shoes design like that? So we use an old gas tank in Beijing, okay, and turn that into a museum space for the shoe. And basically, when you start interacting with the space, when you're stepping on the floor, the whole space start moving, like mimicking the way how art and culture works with how that's inspiring for the technology of the shoe. This is the world's biggest e-waste recycling factory that we're also building. It's actually located in Taiwan. E-waste is recycling iPhones, Apple computers. All the surfacing of that building is actually made from all the computer leftover waste, which including glass fiber, aluminum, and some of the nylon and PCs that's left from, imagine, DVDs and all the television, LCD screen casings. And I just want to quickly, this is already almost finished. It will be done in April, and it will be on National Geographic Megastructure again. And I just want to quickly show you just designing a solar integrated and this recycled material system. You have to go through quite a lot of work in terms of including energy calculations for the client. It's wind dynamic analysis, all the way to all kinds of stress, displacement analysis, all the way to assembly analysis, price analysis, 3D printed models, material analysis. All kinds of testings are required for buildings, ASTM, fireproofing, storm, many like failures, of course, when we are doing all kinds of material testings. And museum spaces already using this material, handrails. These are all buildings that we're currently building in Asia. This is actually a botanical garden and a movie theaters, all made from trash. And this is a building, try not to use any decorations, just using cement, the raw cement as structure and decoration all together into one surface, at the same time achieving all the insulation value that's needed for a sustainable building. So trying to minimize the amount of layers we use in buildings. And we have many failures, including a solar wind powered boat made from trash. And failure means the solar didn't work. So And then of course it also sank because we totally forgot that our material actually had organic fiber inside. After you saturate the water for 3 days, after a long time, the fiber actually gets saturated and actually start to leak water. So that's why that's the fake photo of us like lifting off the water to dry. So